3.1 is called algebraic expressions, and an algebraic expression is going to be an expression, and up until now all we've talked about are numerical expressions, numerical meaning number, and those were just regular problems. Anything that we've done so far has probably been a numerical expression, but now when we get into algebra we're going to add one more piece. So an algebraic expression is going to contain numbers still, operation symbols. Most of the ones we deal with are addition, subtraction, multiplication, and division. And then we're going to start including one or more variables. And we're going to talk about what variables are coming up in this video. And each part of an algebraic expression is called a term. And again, we're going to take a look at that here coming up in just a minute. So this is an example of an algebraic expression, and we're going to break down the parts of the algebraic expression that we just wrote about a few seconds ago, and we're going to get to know the parts of the algebraic expression here. So the first vocabulary piece that you're going to hear a lot more often now that we're dealing with algebra is this letter that represents one or more numbers, and that's called a variable. And again, it can be any letter in the alphabet, but if you see a letter in an expression, then it's representing a variable, and it means it's representing an unknown number. The numerical factor, they call it, that is going to look like the number directly attached to a variable is called the coefficient. And basically this coefficient here tells us how many of this variable we're dealing with. So it's going to be multiplication, of course, because we've got the number directly attached to something. Up until now we've only had it attached to parentheses, but if you put a number directly attached to a variable, then this is called the coefficient, and it means multiplication. It means 5 times whatever your variable is. In this case, it means 5 times the letter P. The last part of this algebraic expression is over here, and any term, and again we'll talk about that in a second, but a term is all of the individual parts of the algebraic expression, but a term without any variable is called a constant, and in this case the 4 is a constant because it's a 4 no matter what. Over here, since we don't know what the variable represents, this number could change depending on information we get about what that variable is going to represent. But 4 is going to just be 4, so we call any of those numbers without a variable a constant. And just to remind you again, we were saying that each part of the expression is called a term. So these underlined parts are each one term in the algebraic expression. So 5 times P is one term, and then 4 is another term. And the first thing that we're going to be doing is just practicing getting to know all of these vocabulary words. For example 1, we're just going to be identifying the parts of an algebraic expression, and we're being asked to identify the terms, coefficients, and constants in each expression. So we're going to set it up like this for our practice, and again, once we do it like this in the video, you'll be setting it up like this for practice problems too for a little while. And so the first thing we have to do is identify any terms. And remember, terms are individual parts of the expression. So one term that we have here is 5x, or 5 times x, and then another term that we have is just the 13. And so we're going to just separate those by commas. We're not going to put the addition sign in because that's an operation symbol, but it's not a term. And we're not going to separate these two for right now because this whole thing is part of one term. And you can kind of tell a term apart usually by the operation symbols. They're usually in between your terms. The next thing we look at are the coefficients, and again, remember the coefficient is attached to the variable, tells us how many x's we're talking about, and in this case, our only coefficient is 5. And then finally, we're looking for constants, and the only constant in this algebraic expression is 13 because, again, it doesn't have any variable attached to it, so it's going to remain the same. So now we can tell our terms apart from our coefficients and our constants. Okay, for part B, we're going to do the same thing we did before. We're going to identify the terms, the coefficients, and the constants in this algebraic expression. And again, you might notice that there are a couple of operation symbols this time. There are two addition signs. So the terms are usually separated by those. So one term is 2 times z to the second power. Another term is the y that's in the middle. And another term is the 3. And notice one thing they're not asking us to do is to actually just name all the variables, but we have a couple of them this time. There's a z and a y, and they mean different numbers. We don't have to solve for them for right now, we just need to recognize that they mean different numbers. The next thing we are going to look at, though, is coefficients. And one coefficient is the 2 that comes before the z, or before the z squared, I should say. And so that's a coefficient. But this one has a little bit of a tricky step to it. If you look at the y, the variable, a coefficient always gets attached to the variable to tell us how many. And even though you don't see a number here, when there's just one variable, that actually gives us the idea that there's one, and we just don't write the one, but there is another coefficient that means in this case, which is 1 because of this 1y. And then finally, again, there's just one constant, which is the 3 up here. So the terms are 2 times z to the second power, y, and 3. The coefficients are 2 from up here, 1, because even though we didn't see it, we know that when you have one variable, there's a coefficient of 1, and this 3 is your constant. Example 2 is writing algebraic expressions using exponents. So we're just going to practice again writing each expression using exponents. And the first one is d times d times d times d. And remember that exponents mean the base, which is whatever you're getting multiplied. Normally it's been numbers, now it can be variables. And then you write it how many times it got multiplied by itself. So in this case, d got multiplied by itself 4 times, so we would say d to the 4th power, which meant multiplication, d times d times d times d. And for letter B, we're going to do the same thing, but we are going to include a coefficient this time. So we've got 1.5, or 1 5/10, times h times h times h. And the way we would write that would be to put the coefficient first, so that 1.5, because it's only getting multiplied in there as the first part, and then times h. And remember, we don't have to put a multiplication symbol in there, because if you just put the coefficient right next to the variable, it means multiply. So you might want to write that down if you'd forgotten that. Means multiply when they're right next to each other. And then we have to count how many times we multiplied h by itself, and it was 3 times. So we would say to the 3rd power, or 1.5 times h to the 3rd power. Example 3 is about evaluating algebraic expressions. And remember, evaluate just usually means find an answer or get it as close to simplified as you can. So we're evaluating k plus 10, and the only way we can actually evaluate this is if we are told what the variable equals. And when we do this, one thing you're going to find out about algebra, whether you like it or not, you're going to have to start showing steps. Again, even when you can do it in your head, which I totally understand that you guys can do, you're going to show steps. So the first step we do is to go ahead and write that original algebraic expression. And one thing you'll notice about variables is they're lowercase all the time, so I'm trying to make sure that that looks noticeable. And so our expression is k plus 10, and then they told us right here that they want k to represent 25, and then we keep everything else the same, and that brings us to the final step, which is to simply add those together. 25 plus 10 is 35, So our evaluated expression would be 35. And again, I totally understand that you guys can do the stuff in your head, but after we start evaluating a few expressions, the next thing we do is start solving equations, and that really does require showing all of the steps. So just go ahead and get in the habit of it now, please, and I promise it will all pay off in the end. For example B on this one, they're asking us to evaluate 4 times n when n equals 12. And just a quick reminder, because this is going to come up a lot again in algebra, you can write the product of 4 and n, and product means multiplication. You can write that a couple of ways. You can do 4 with a dot for multiplication times n. You can do 4 right next to n because that means multiply, or you can put either the 4 or the n in parentheses right next to the other one, and that would also mean multiply. We are going to evaluate that though, and again we're going to write the expression, which is 4 times n. We're going to substitute that times n piece for what we think n is, and they're telling us that it is equal to 12. And then I'm going to slide that up just a little bit, give us some room there. And then we just do the multiplication. And again, if you're fine with 4 times 12 in your head, go for it. If you have the multiplication chart, that's fine too. Or if you need to do the side math, that's also fine. But in the end, you figure out 4 times 12 is 48. So when we evaluate that expression, we get a final answer of 48.